Thanks EFI for giving me this opportunity once again. Today we'll be talking about how to deploy this one-wire bus technology, particularly using this DS18B20 digital temperature sensors. There is a genesis of this project. It's a small project. In a power plant, we need to monitor a few temperature, motor temperatures. So the motor temperature, normally it remains below 120 degree. So we wanted to monitor the motor temperature. So we purchased a whole lot of DS18B20 from one site, internet site, and we got it pretty cheap. So finally we found that we needed 10, and we ended up with 100 DS18B20. So how to use those digital precision temperature sensors effectively. So we started exploiting those sensors, and we found that they can be jolly well used in a one-wire technology where a long length of bus can be used. So that's how the whole program started. And if you see it, it was how beautifully we found, we solved quite a few problems. And if you know the technique, you can find it very useful, yet very efficient and cheap. Before that, let me tell you what this CT stands for. CT stands for cooling tower. Those who are from Delhi, they must have used a desert cooler. So these cities are nothing but big desert coolers. For a 500 megawatt thermal power plant, we need to handle 1,650 tons per hour steam that is produced in the boiler, that goes to the steam turbine. There it expands, runs the turbine. At the end of the turbine, the generator is connected, it produces electricity. And after that, that whole amount of steam, it is condensed in a condenser. Otherwise, what will happen? We had to use up a huge amount of water. So water becomes steam, steam becomes water again, so that the water is reused again. But again, for making a steam up to converting it into water, we have to take latent heat of steam out. So cooling tower is nothing but that desert cooler of big capacity. It sends 60,000 tons of water to cool that steam. That steam becomes cooled down to water. And this water, this is called circulating water, this goes around this cooling tower. So that's why the CT stands for. It has got 10 huge fans, and below that fan, just like your desert cooler, this water is spread. Or in desert cooler, you use that, what is the term that called hose. Okay, here we use this fills. We use fill packs where from that water goes in a very circuitous way, and water gets heated up, and steam is cooled and cooled into a condenser. And this the steam is cooled in condenser, and this water, whatever is heat is given to that, this taken out from the steam, this water comes here in this cooling tower, and it gets cooled by the flow of air. The way it has 10 helicopter-like big propellers which pulls air. In नीचे जो वो दिख रहा है, this it gets air sucked from this bottom portion. If you see the small picture in picture here this water is finely divided into small droplets, and water air comes into contact of it, and it gets cooled down. So this is a cooling tower, typical cooling tower for a 500 megawatt steam turbine. Well, so now water is cooled here to the tune of 11 degrees centigrade. Okay, so this is a whole cooling tower looks like. You have 5 into here it is 6, but normally there are 5 into 2. The 10 towers are there. Their water is cooled down. It handles 60,000 meter cube, the tons per hour water. And this 1,600 tons per hour water, the steam is condensed from 14 degree by 11 degree to 10 degree. And you just imagine if steam temperature is risen by 1 degree centigrade, there is a loss of 37,000 rupees per day. And in a year, considering some overhauling period, some stoppage of units, it becomes 1.22 crore rupees per year loss. So monitoring of city temperature for each of these cells is very important. We have to find out the culprit cell. These are called cells. Each cell, there are 10 cells, and we have to find out this culprit cells, and we have to rectify it very quickly. Otherwise, this huge amount of loss is incurred every day and every year. Well, so that was the genesis of the program project. So we put these temperatures in these towers below the bottom portion of this tower, and we monitor temperature all tied up on one bus. And if this wire goes around here to here and finally ends here, at the bottom portion somewhere the operator sits, and there it is put in a microprocessor, and a small display unit is used. So there he can, one look, he can find out that which cell is malfunctioning. And we have put not one, we put 5 temperature sensors per tower. So for 10 cells, 50 sensors we used up. Let's see how. Advantage, see, there are a variety of DS18B20s are available, and this is the variety we have used up. This is the variety we have used. This is metal encapsulated and waterproof, because cooling tower water, it is only water and steam. So yeah, these sensors has to be waterproof, otherwise the corrosion will take place. Now there is a unique advantage of this DS18B20, this digital temperature sensors. It has got a resolution nature of, there are 4 resolution varieties are available. 9-bit is the fastest. It takes very small time, 0.5 degree means if we measure 44 to 33 degrees centigrade, 44 to 33 degrees centigrade, it can go up to 33.5, or this, if it becomes 0.6, it will go to the next round number. But on 10-bit, it takes little longer time, 187.5 milliseconds, and it becomes more precision, 0.25. And that way, if you use 12-bit, it takes longest time, 750 milliseconds, little less than 1 second, but precision is very high. And we'll come back to this video link later. And this is a typical look of a digital temperature sensors DS18B20 when it is metal encapsulated. The temperature range is minus 75 degrees centigrade to 150 degrees centigrade. So within this, you can have temperature sensor monitoring capacity to this tune of precision. See, that was the time this project was hatched up 2.5 years back. 2.5 years back, that time this 100 pieces of DS18B metal encapsulated temperature sensors was available for $100. And today, in this period of lockdown and so many things, the price has further reduced. For $84, you can get 100 pieces. In Amazon, it is a little bit costlier, but a lot of these online vendors are available. Not this one particularly. There are many more where you can get it little less than $100. You can have 100 pieces of this temperature sensors. And the major expenditure of this project is this 3-core 6 square millimeter aluminum core cable. You have to have आपको जितना length होगा, you have to laid bars of 3 core wires where starting from the first sensor up to the last sensor. You have to have a very good, not once, the 2 numbers of 5 volt, 4 ampere PA power supply unit. One will be, one each will be both the ends. One will be both the ends. This is called parasitic power supply. You can take it from the microprocessor end, but that way there will be loss of voltage due to internal resistance of the cable, the other end. So to combat that, we propose to have 2 power supply unit, and we have 2 power supply unit. And for a longer where you can increase the this capacity. And see, because we put it in the cooling tower, a lot of times the operators is engaged for many other towers, so he may not be available to monitor the temperatures every now and then. So we put an uploader there. That 868 megahertz SS transceiver uploader we have put at the end of that bus where the microprocessor is fitted, and therefrom it uploads to the control tower, control room, which is situated around 300 to 400 meter in a air distance. Normally what happens in a typical power plant setup, what happens, the units are in one line, and the cooling towers in all the cooling towers are also in one line, and the control tower sits just in between both these two lines. Means it's like a parallelogram, and at the cross section of the diagonals the control tower is situated. So that way the distance is not more than 300 meters. But cabling is a very big task in a power plant, because a lot of things are already fall in between. So airline this communication in the air using the small transceivers, it's very easy, very cheap also. So what happens, you have all those temperature sensors are connected on the bus. On the 10 cells, you have laid the bus, and each cell you have laid a small bus where these temperature sensors are connected to each other in a form of small net. And we have given two softwares. One software is for knowing the address of the individual 18B20 temperature sensors. See, 18B20 temperature sensors, literally you can put 1 billion, believe me, 1 billion temperature sensors you can put on the bus of 500-meter length. But practically, we ended up with putting 50, but you can go up to 500 also. There is no problem. But literally, the address is feasible to have 1 billion temperature sensors on one bus. And the second software we have provided, where what you will do, after knowing the address of all these 100 sensors or 50 sensors what we have used, we'll put those address in the second software and we'll call the temperatures by those address. And that way it becomes very easy. We put it in an array. In the program, we'll see we put all those address in an array. And we are calling it by the array elements, 1 to 50. So here we have put 150 sensors, then 100, 150 in another project. And for a big boiler project like monitoring the hot air leakages in a 500 megawatt boiler, you can have quite a few number of bus where you can connect hundreds of sensors in each bus. Before coming to the schematic, I can tell you that there are a lot of areas we are putting this single wire bus system. One is that pulverizer fuel flow mapping. In a big power plant, what happens? There are 6 pulverized fuel mills. They get coal, they crush the coal, and then send that coal by pneumatic conveyor to the boilers. So for each that pneumatic conveyor, we are putting this one wire bus temperature monitoring system. Because what happens if there is a leakage or there is a bend, so at those bends, this fuels has a tendency to get choked up. So when it gets choked, then cleaning of those fuel path is very, very nasty job. So to get rid of that, we are putting this bus there. So nowadays, again, this government has pushed up to use the husk. You know, this Haryana and Punjab end, that in the evening, during summertime, that after harvesting, they fire a lot of husk. So we are buying those husks from those farmers and we are putting them simply in the mills. So in the mills, along with coal, they are getting crushed and going to the mills for firing. So firing husk is also a very bit sensitive, because husk has got a flash point much less than the coal. So we have to monitor the temperature more precisely. So we are putting up this temperature sensors in some of those projects situated in and around Delhi and Haryana. In the conveyor also, we have thought of this project. In the conveyor also, we'll put a long bus and there we will be monitoring these conveyors idler temperatures. Idlers are those idle pulleys on which the conveyor belts runs along. And this, yes, the solar PV panel, one health parameter of solar PV is that monitoring the temperature, the base matter temperature. If a solar panel is defective, then one temperature which one signal you will get, that panel temperature is increased. So monitoring the solar panel PV temperature all stretched along a 500-meter field can be done very easily, putting a small 1-wire bus. Well, I'll come back to the circuit diagrams. See, this is the typical. It can be many more. This is the typical circuit diagram of this project. This DS18B20, you see all the grounds are connected to the common ground, and all the VDDs are connected to the common VDD. This is a 5 volt. Okay, and all the digital the signal wires are connected via 100 ohms resistor. 100 ohms resistor, and one is that 470 ohms resistor between this common signal line and positive line. And there are two power supply units. One is that end, this is the parasitic power supply, and one is the main power supply here. This is the typical microprocessor. This is the display unit, and this is the typical uploader, radio uploader. See, it gets all those 50 to 100 to 500 temperature sensors data. It comes here. When you call them by address, the temperature comes depending upon the resolution you have set. It comes to the microprocessor, and microprocessor put it in a file, CSV file, and uploads. And this uploaded signal again is received by the receiver, which is nothing but another computer laptop having a processing output, and there it is monitored cell wise. So that's very simple. And now I'll show you the testing what we have done, the pilot testing.
Yeah,
See,
yes.
I have jammed 15 sensors. I have jammed 15 sensors on one bus, and this 470-meter long cables are just here, all mixed up. And look at the ends. This end is here. This is a simple electrical 6 square meter cable. This is an ESP32. And the whole temperature is appearing in this serial terminal. So that was the concept on which we dare to start this project. And ultimately, we laid a 300-meter long cable in cooling tower, and there we put this 50 temperature sensors there, and those temperatures are arriving along that bus with a small display unit at the ground level where the operator sits. But because the operator moves around all the cooling towers, we have 13 cooling towers. So we have put a small uploader there on the roof of that cooling tower, and the data uploads to the control tower, and there they monitor it. So that is the total project, starting from that genesis, that concept, then ultimately the final project on the cooling tower. Nowadays, we have put a few bars in some of the units where we are finding a lot of chokage of these pulverized fuel coal mills. And there also we are beautifully monitoring it. So that's all about the project. Now I'll ask Mr. Aseni for open up the question answer session.
Yes, sir. Now you can ask any question. We have one question, sir. How to monitor panel temperature?
Please tell me again.
How to monitor panel temperature?
Yeah, for monitoring panel temperature, what we'll do inside of the panel. See, normally what happens nowadays, a lot of relays in the form of numerical relays and other panel monitoring devices are put on the switchgear panels. So what you have to do, you have to run a small bus there inside that cable, inside that panel, You have to run a small bus inside that panel, and you have to put a temperature. What is the transistor type that monitor the sensor or this metallic temperature sensor on the body of that panel inside, and take that bus out. And at the end of the bus, you put a monitor or whatever it is. That's easy. The remaining part is easy. Once you let that bus, the remaining part is easy.
Okay, sir, we have one more question. What is operating voltage of sensors and specifications?
This DS18B20 runs on 5 volt up to 3.3 volt. Voltage needs to be very stable.
Sir, we have one more question. Did you use ESP32 for panel project?
Yes, I started with a Arduino, but normally I prefer ESP32 because it's a more powerful microprocessor, and it can do many more things. So I always prefer ESP32, and it runs on 3.3 volt. So that's another advantage.
We have one more question, sir. How do you manage the voltage drop issue for long distance?
For managing voltage drop issue, you have to use the cable. You have to use very good quality cable. One is that this 4 to 6 ampere power supply you have to use, and you have to use two power supply. One is at the microprocessor end, another one is the other end. And you can put a few capacitors in between. And cable you have to use minimum 6 square meter mm, or you have to use 3 square mm copper cable, because copper cable has got a very good conductivity. So you won't find less voltage there. And you better can do one thing, that you use 5 volt. You use 5 volt, and yes, 5 volt. For 5 volt, that voltage drop will be less. See, for smaller voltage drop is more, for higher voltage drop is less. But for 300 meter cable or for 350 meter this polarized fuel milk project, we have used 3.3 volt, and we have used 2 SMPS on the both ends, and we never faced any problem. Yes.
This sensor use really time energy management system. Is it possible?
So the time energy, what is that? Because cooling tower, we are monitoring the temperature. The moment the cell temperature deviates from the design temperature, we have to take care of that cell. Otherwise, it's a huge loss. And the DS18B20 measures temperature to a very, very fine degree of precision. So that's the advantage. So precision, if precision is the issue, you can use the DS18B20 jolly well, because you got a very good precision with this temperature sensor. If that answers your question, I think.
You want to ask that can it be converted into the product that can be deployed?
Yes, why not? Thing is solving an industry problem. So if you can come forward, the industry will accept you, because this is a real-time problem, a real-life problem, and we have solved it. See, in fact, this lot of these big companies, Siemens and all other these companies, they are not doing anything big. They are doing the same thing what we are doing, and they are putting it under big name, big package, and they are selling you.
Someone had asked which power plant do you have installed?
We have this project. It is a working project.
Okay, thank you, sir. Thanks a lot for such a wonderful session, and thanks everyone. Hope you got a lots of learning from here, and thanks a lot, sir.
Yeah, thank you, Asini. Thank you, EFY, for giving me this opportunity to talk to you guys.